Hello children, welcome to Math Park. Let us start exercise 17B of the topic circles from the book Concise Selena class 9 ICSE. Each and every question is going to be solved over here. So if you like it, please share with your friends. And if you are new to the channel, please subscribe. So we start with the first question. The figure shows two concentric circles and AD is a chord of a larger circle, and you can look at this BC is the chord of a smaller circle and AD is the complete line segment. So you have to prove that AB is equal to CD. Now let us drop a perpendicular from O. So let us say OM is perpendicular. So we have OM is perpendicular to AD and also perpendicular to BC. So therefore we know that perpendicular from center bisects the chord. Perpendicular from center bisects the chord. So therefore you have AM is equal to DM. Okay, this is our equation number 1. Now again, BC is the chord of the smaller circle. So you get DM is equal to CM. Now what should you do to this equation 1 and 2 so that you get AB and CD? So we know that this entire AM minus BM you get AB. So let us do equation 1 minus equation 2. So you have AM minus BM is equal to DM minus CM. And this is how AM minus BM is nothing but AB and DM minus CM is nothing but CD. And hence we have done with question number 1. Moving to question number 2. A straight line is drawn cutting two equal circles. Equal circles, that is congruent circles, and passing through the midpoint M of the line joining the centers O dash. You have to prove that chords the chords AB and CD, which are intercepted by the two circles, are equal. So you need to prove AB is equal to CD. These two chords are to be proved equal. Now what do we do for that? You have to prove that AB is equal to CD. Now when will AB will be equal to CD? If these chords are at equal distance from a center. So let us drop the perpendicular from O. So we say, let us say OX and let us say O dash Y. So we draw the perpendicular OX and O dash Y on the chord AB and CD respectively. And let us start proving these two triangles forward. What is our target? Target is proving OX is equal to OY. So let us start with the proof. So we have in triangle OMX and triangle O dash YM or O dash MY. Let us take this M in between so that the correspondence is very, very important when we are proving triangles congruent. So we have this angle X and angle Y 90 degrees. So you have angle X is equal to angle Y is equal to 90 degree each. And then let us take this angle 1 and 2. So you can number the angles instead of writing complete name. So you have angle 1 is equal to angle 2. These are vertically opposite angles. And you have OM is equal to O dash M. So you have OM is equal to O dash M. Why? Because M is the midpoint. M is the midpoint which is given to you. M is the midpoint and it is given. So therefore, you have triangle OMX is congruent to triangle O dash MY by AAS. This angle side. And therefore, you have OX is equal to O dash Y by CT. Now, since the distances from the center are equal, you can say the chords are equal. So we can say that if the chords of congruent circles, which are equidistant from the center, are equal. Okay, we have seen so far that when it is for the same circle, same thing applies when the circles are congruent. So therefore, you get AB is equal to CD. Got it? M and N are the midpoints of two equal chords AB and CD respectively of a circle with center O. Prove that the first angle BMN is equal to angle DNM and angle AMN is equal to angle let us join OM and let us join ON. Now we are given that this is the midpoint, M is the midpoint and N is the midpoint. So if a line is drawn from a center to bisect the chord is perpendicular to the chord. So therefore angle AMO is equal to angle CNO is equal to 90 degree, and you have angle BMO is equal to angle DNO is equal to 90 degree. Let this be our equation number 1 and this is our equation number 2. Now we are asked to prove angle BMN. So let us join this. So you are asked to prove angle BMN. This angle is equal to DNM. So since OM is equal to ON, equal chords are equidistant from the center. So you have OM is equal to ON. So therefore, you get these angles equal. That is angle 1 is equal to angle 2. This angle 1 and angle 2 are equal. So therefore, you get angle 1 is equal to angle 2 by isosceles triangle property. Now we want to prove BMN. So what should I do to get BMN, this part of angle? So from this BMO, if I subtract angle 1, equals are subtracted from equals, you get the, it get cancelled. So therefore, we do equation 2 minus equation 3. So that is angle BMO minus angle 1 is equal to angle DNO minus angle 2. Since they are equals, now what is left over here? You are left with angle BMN minus this angle 1 is nothing but angle BMN, and DNO minus angle 2 is nothing but angle DNM. So this is equal to angle DNM, and thus we are done with the first part. Now for the second part, what should we do with this angle 1? So what should we do with this equation number 1? Let us add equation 1 and 2. So let us add equation 1 and 3. 1 and 3. So you get angle AMO plus angle 1 is equal to angle CNO plus angle 2, and angle AMO plus angle 1 is nothing but angle AMN. So which is angle AMN, and angle CNO plus this is nothing but angle CNM. So which is equal to angle CNM, and thus we have done with question number 3. Question number 4. In the following figure, P and Q are the points of intersection of two circles with centers O and O dash. The straight lines APB and CQD are parallel to O dash. Prove that O dash is equal to half AB and AB is equal to CD. So let us drop a perpendicular from O. So let us draw a perpendicular from O. They say OM and O dash N. So we drop the perpendicular OM and O dash N. Now, since this is a perpendicular, both angles are right angles. So therefore, you get OM is parallel to ON. So since you have angle M and N, you have angle M is equal to angle N is equal to 90 degree. You get OM parallel to O dash N, and already you are given the lines, intersection of two lines, straight lines, and these two lines are parallel. So therefore you get OMNO dash is a rectangle. It is a rectangle. You get this as a rectangle. So therefore you get OO dash is equal to MN. OO dash is equal to MN. Opposite sides of rectangle are equal. And Mn is nothing but Pm, which is equal to Pm plus Pn. Now, Pm is equal to half of AP because perpendicular from center bisects the chord, and Pn is equal to half of PB because reason for both of this is perpendicular from center bisects the chord. Perpendicular from center bisects the chord. Okay, bisects the chord. Which chord? AP is the chord of the smaller circle and PB is the chord of the bigger circle. Now, since your OO dash is equal to PM plus PN, let us put here, you have OO dash is in place of PM, I'll put half of AP, and in place of PN, I'll put half of PB. So let us take this half common, you get AP plus PB, and AP plus PB is nothing but AB. So this is how you get OO dash is equal to half AB, hence proved with the first part. We have done with the first part. Now for the second part, you are asked to prove AB is equal to CD. So what we can do, we can drop the perpendicular from here. We can drop the perpendicular from here. And let us say that OX is perpendicular to CQ and O dash Y is perpendicular to QD. And then we can say that similarly, we need not prove that. So similarly, we have O dash, we have O dash is equal to XY, and same way we will be able to prove O dash is equal to half of CD. So from this equation 1, half of AB, and then this is equation 2, half of CD. So we get AB is equal to, or half AB is equal to half CD, because both are equal to O dash. So this implies AB is equal to CD, and thus we are done with the second part. Two equal chords AB and CD of a circle with center O intersect each other at point E inside the circle. Prove that AP is equal to CP. Now let us draw OM perpendicular to AB and ON perpendicular to CD. OM perpendicular to AB and ON perpendicular to CD, and join OP. So now we will be proving these two triangles congruent. So in triangle ONP and triangle OMP, you have angle N is equal to angle M is equal to 90 degree by our construction. Then you have OP is equal to OP common. You have OP is equal to OP is common. And ON is equal to OM. Why? Because equal chords are equidistant from center. Equal chords are equidistant from center. So this is how we could prove this triangles congruent, equidistant center from center, and therefore you get triangle ONP is congruent to triangle OMP by RHS. This is congruent by RHS, and therefore you have PN is equal to PM by CPCT. So let this be our equation number 1. Now we know that perpendicular from center bisects the chord. Since the perpendicular from center bisects the chord, we have AM is equal to BM, and we also have CN is equal to DN. CN is equal to DN. Since the chords are equal, their halves are also equal. Chords are equal, their halves are equal. So therefore, you get AM is equal to CN. AM is equal to CN. The halves of the chords are equal. Let this be our equation number 2. And you also get similarly, since the BP is this, so you get DM is equal to DN. Let this be our equation number 3. Now, we want to prove AP is equal to CP. So what should we do for this for getting AP? You need to subtract PM. So we will be now, since PN is equal to PM, we can also write PM is equal to PN. This is our equation 1. So we'll do equation 2 minus equation 1. So we have AM minus PM is equal to CN minus PN, and AM minus PM is nothing but AP, and CN minus PN is nothing but CP. So thus we are done with the first part. Now for the last part is we have to prove BP. So how will you get BP? So it will be BM plus PM. So we have BM here and PM over here. So we will have to add equation 3 and 2. So let us add equation 3 and equation 1. Equation 3 and equation 1. So we get BM plus PM is equal to DN plus PN. Now BM plus PM is nothing but BP, and DN plus PN is nothing but DP, and thus we are done with question number 5. Moving to question number 6. In the following figure, OABC is a square. A circle is drawn with O as a center, which meets OC at P and O at Q. Prove that OPA, this triangle OPA is congruent to triangle OQC. So let us join this OQC. Let me take some other color here. Join O, C and Q. C and Q we join. So now let us start proving this triangle's congruent. So we have in triangle. So in triangle OPA and triangle OQC, you have angle O is equal to angle O is equal to 90 degree because it is an angle of a square. Secondly, you have OP is equal to OQ because they are the radii of same circle. OP is equal to OQ. They are the radii of same circle. Radii of same circle. Now we need the third part. For the third part, what we have here now, see, now OA is equal to OC because they are the sides of a square. So OA is equal to OC. These are the sides of square. So this is how we get the triangles congruent. So therefore, we have triangle OPA is congruent to triangle OQC by what? By SAS. By SAS. Got it? So we did with the first part. Let us do the second. Let's do the second part. We BPC. So let us join this. This is BP. Let us join. And BQA. Let us join this BQ now. So we need to prove these two triangles congruent. Now here again, let us start. In triangle BPC and triangle BQA, we have angle C is equal to angle A is equal to 90 degree. These are the angles of a square. Then also we have BC is equal to BA. These are the sides of a square. They are the sides of a square. Sides of square. And then now you got two things. You got BC and DA equal. We got 90 degree. We need one more part. Now for that one more part, we already know that QOC is equal to OA, that we know. From that, let us subtract the radii. So we get OC minus OP because this is the radius is equal to OA minus OQ. Equals can be subtracted from equal. So OC minus OP we get CP, and OA minus OQ you get QA. You get this as QA, and this is how we get three parts. Now we got this part equal. So therefore you have triangle BPC is congruent to triangle BQA again by SAS. Got it? By side angle side. The length of the common chord of two intersecting circles is 30 centimeters. So we need to read the question and draw the figure, children. So length of the common chord. So we have two intersecting circles here, and length of the common chord. So let us say AB is a common chord and the length of this chord is 30 centimeter. If the diameters of these two circles be 50 centimeter and 34 centimeter. So let the center of this circle be say M and the center of this circle be N. And the diameter is 50. So the radius of the bigger circle is half of 50, which is 25 centimeter. And AN is the radius of the smaller circle, which is half of 34, that is 17 centimeter. Now the line segment joining the centers is the perpendicular bisector of a chord. So therefore, this is the MO or OM bisects the chord AB. So if the length was 30, this becomes 15 centimeter and 15 centimeter. To find the distance between their centers, we have to find MN. MN is what we need to calculate. So we got two right triangles here. So let us find OM by Pythagoras theorem. By Pythagoras theorem, let us find OM, which is root of 25 square minus 15 square. 25 square is 625. 15 square is 225. 625 minus 225 is 400, which is root of 400 is 20 centimeter is OM that we got. Now let us find ON. So ON is equal to, we use this right triangle now, which is root of AN square, that is 17 square, minus AO square, which is 15 square. 17 square is 289 minus 225, which is a root of 64, and root of 64 is 8 centimeter is your ON. And the distance between their centers MN is nothing but OM plus ON, that is 20 plus 8, which is equal to 28 centimeter. Got it? The midpoints of two chords of a circle. So we have a circle and we have two chords over here. So let us draw a circle and then two chords. So the chord AB, let us have, say, this is chord AB and then this is chord CD. Say M is the midpoint of chord AB and N is the midpoint of chord CD. And it says that the line joining the midpoints of two chords passes through the center. Prove that the chords are parallel. So the line joining the midpoints is passing through the center. This is O. We have to prove that the chords are parallel. Okay. Now, since it is the midpoint and the line which joins the line from a center which joins the midpoint of a chord is always perpendicular to the chord. Okay, line. So this is the second theorem that we learn. Line drawn from center of a circle, to bisect a chord. So since we are it's meeting at the midpoint, so of course it is bisecting. To bisect the chord is perpendicular to the chord. Is perpendicular to the chord. This is the symbol we use for the perpendicular to the chord. So therefore, you have this angle as 90 degree. Same way, you have this angle also as 90 degree. So you have angle BMON is equal to angle CNM is equal to 90 degree. And these are alternate angles. These are alternate angles. Since alternate angles are equal, you have AB is parallel to CD. So if the alternate angles are equal, AB is parallel to CD. Or we can take even this angle as 90 degree. You can take co-interior angles are supplementary. You have AB is parallel to CD. Question number 9. In the following figure, the line ABCD is perpendicular to PQ. ABCD is perpendicular to PQ, where P and Q are the centers of the circles. Show that AB is equal to CD. You are asked to show that AB is equal to CD. Now, perpendicular to PQ. So this already we know that this is perpendicular and we know P is the center. Let us say this is point N. So PN is perpendicular to AB and QN is perpendicular to AD again. So therefore, we have perpendicular from center bisects the chord. Perpendicular from center bisects the chord. Therefore, you have AN is equal to DN. And also you have BN is equal to CN. So let this be equation number 1. Let this be equation number 2. Now, if AN is equal to DN, we need to prove AB is equal to CD. So what should be done? AN minus BN, you will get AB. So we have equation 1 minus equation 2. Let us do. So you have AN minus BN is equal to DN minus CN. So AN minus BN is nothing but AB and DN minus CN is nothing but CD. So hence we have done with the first part. Now second we want to prove AC is equal to BD. So what should be done for having AC is equal to BD? So AC is equal to BD. For that we can write CN is equal to BN. We can No, 2 into 3. 2 into 3 is same as 3 into 2. Just rearranging this. Cn is equal to Bn. Now we want to prove AC. So what should be done? So An plus Cn you get AC. So this is again equation 2 only. We just have, change the places, flip the places. That's it. So let us add 1 and 2 now. Add 1 and 2, equation 1 and 2. You have An plus Cn is equal to Dn plus Bn, Dn plus Bn. Now An, this is An plus Cn, you get AC, and Dn plus Bn, you get Bd. So this is how we are able to prove AC is equal to Bd. The last question of the exercise, AB and CD are two equal chords. AB and CD are two equal chords. So this is your chord AB and the chord CD. They are two equal chords and they intersect each other at right angle at point P. They are intersecting at right angle at point P. If OM is perpendicular to AB, so OM is perpendicular to OB. So here OM is perpendicular to AB and ON is perpendicular to CD. ON is perpendicular to CD. We need to prove OMPN is a square. We need to prove OMPN. In quadrilateral OMPN, we have all angles equal. So we have angle M is equal to angle P is equal to angle N is equal to angle O is equal to 90 degree. So therefore, this is a rectangle. Therefore, OMPN is a rectangle. Each angle is right angle. Is a rectangle. Now, for proving a rectangle to be a square, we need to know adjacent sides are equal. So we have, since the chords are equal, we have AB is equal to CD. Therefore, you have OM is equal to ON. Equal chords are equidistant from center. Equal chords are equidistant from center. Equidistant from center. So therefore, you got OM and ON equal. Now, since the adjacent sides are equal, so therefore you get all sides equal. So you have OM is equal to ON. But since it is a rectangle, you have OM is equal to PN. And also you have ON is equal to PM. Also you have ON is equal to PM. So therefore you get all the sides equal. Since all the sides of a rectangle are equal, we can say that therefore OMPN is a square. Or only if we say that the adjacent sides of a rectangle are equal, it becomes a square. Got it? So thus we completed with exercise 17B. Immediately coming up with 17C, children. If you like the video and it is helping, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.